Awesome. Welcome to week 6. Today, we're going to talk about AI and labor. So, we see headlines like AI is going to take your jobs or AI is going to cause mass unemployment, things like that a lot these days. So again, like I think I want to start with this broader component of framing the debate clearly, right? So last week, with data centers, we started with something similar with an argument that says, okay, there are certain things where you cannot make a binary argument, or you cannot at least strongly hold a binary view because the evidence will be somewhere in the middle and it's very complicated and things like that. And this is one of those questions. The problem with asking a question like, will AI take your jobs, is that it's just too blunt, right? Like, so if you, I mean, the question is a binary. Like, so if you say yes, then it leads to panic. If you say no, it'll take leads to dismissal. But I think the answer is somewhere in the middle. And the point of this lecture is to try to answer a question like this without this binary decision of like, okay, yes or no. So the better question that we want to answer is, where would this affect, right? Where would the effect of AI on labor market show up, and where is it starting to matter? Uh, so the main point that we want to make is that at least currently it is having some effects on the margins. So we'll see. So your low end jobs or your high end jobs, like there's certain places where there is disproportionate impact right now. And but I think it might come to like a broader impact pretty soon. Like, but how is the shape of that going to look like? Things like that we're gonna look at, and we really want to think of in a much more careful way. Not think of jobs as one single thing. Like, we'll make some arguments about that, but it's things about, okay, what are the tasks that are being replaced? What are the output being produced? Junior hiring, wages, work intensity, bargaining power. Like, a lot of these factors do also play a role in the job debate. So again, like, this is my bias here is, but I think it's overall true as well, is that it can be productivity enhancing very, very well, but it can also weaken other places where some workers might be impacted disproportionately more than others. So I think by the end of this hour or so, like, we want to get clarity on this discussion, like read through a bunch of really good work by some economists and so on. Okay, so last week we saw this huge build out, right? Like, huge build out of data centers, a lot of capex, a lot of infrastructure, electricity, and things like that. And the this infrastructure is being built with the assumption that there's going to be demand, and the demand is mostly, one of the clean ways of demand is productivity, right? Like, where AI creates a large economic value both personally and professionally. So companies will invest a lot of money in making their workers, and firms use more AI, and like that creates demand and so on. So that's it's very linked, right? Like, this sort of infrastructure build out and the jobs effect, right? Like, so we don't know if the link is very clear, like that, if it's build it and they will come, or not. And I think part of today's lecture will also kind of try to answer that. So we want to ask if uh, the value that these data centers and the infrastructure has already been built is creating is showing up in actual work, or is it mostly in like forecasts, investor expectations, and so on? Like, is it still futuristic, or are there current effects already that are being shown? Uh, Before we go deeper into the evidence and then discussion, let's try to provide some high-level clarity on, when thinking about this AI and jobs discussion. There are four main things I want to clarify. So for other slides, the first is this sort of distinction between methods, application, adoption, and impact. So this is something that this Narayanan Kapoor piece, the normal technology piece, makes. And so in labor, it's essentially very important to make this sort of distinction. So let's again recap what that is. The method is that a model can generate text, code, images, and plans, videos, and so on. Application is a product embeds this into a workflow, right? Like so, there's these models. GPT 3.3 has existed for 2 years, but a product that made it accessible is ChatGPT or the GPT whatever embedded in Bing search or something like that. Adoption is like, okay, are people actually using that? Okay, ChatGPT has been released or whatever. Bing search with GPT-4 has been released, but if nobody is using it, that's a different case. And if many people find it helpful and useful, right? Like so, what a firm actually changes their behaviors, and then we finally get to impact, right? Like so, which is the output, hiring, wages, quality, power shifts, things like that, which are what we the headline case of job losses or AI impacts on jobs and things like that. So here, like I think it's very, very, very important to kind of have these four different components in mind, right? So most public arguments make the case from, okay, GPT whatever 5.6 is released. It's extremely good at this passing a bar exam, and so the impact is going to be that all lawyers will be replaced, right? Like so, I think this is an argument that we really need to be careful with recognizing now that we know this sort of a four-step way in which things usually work. Like if someone makes that argument, okay, GPT 5.9, whatever it is, it does really good job at task XYZ. So the people who do that task will be replaced, right? Like so that kind of jumps from method to impact, which is like I think a bad prediction. So passing the bar exam does not mean replacing lawyers. The coding benchmark success does not mean replacing software engineers. But neither does uncertainty mean no impact, right? Like so, if you don't have certainty, it doesn't mean also no impact. Like it's a complex case, right? And so the details are that adoption and availability are not the same. So AI tools can reach everyone instantaneously. Like if you're releasing something online, everyone can have access to it. But it does not mean that existing workflows in a firm or schools or law or trust, habits, these change instantly, right? Like so, this is again like we are seeing this in our own daily lives, right? Like so, you are all part of this university course curriculum. How much are we seeing, the day-to-day life change because of ChatGPT? Like, is this really, massive, or is this somewhat slowish, right? Like, and I'm as an academic, like who is in this space, I feel like it's very slow, and I have to we have to make the case that this is going to happen, even though it's been like 3 years ago, like that GPT whatever has been released, and like there's lots of impacts that might come across. Like so, we're already living through this slow pace of change. So in this normal technology lens, like adoption, diffusion is limited by human, organizational, and institutional change, which is going to be very slow. Adoption is about use, not availability. A tool can be free and online and powerful, but if nobody is using it, or it's not easy to use, or it doesn't makes it harder to change workflows or whatever, like then the adoption will be much slower. And so for the labor consequence is that there'll be gradual uneven reorganization before expecting a clear economy-wide shock. Like so, this is another thing that we should take away from this lecture is that people will say things like, "Oh, AI will cause mass unemployment." We don't know if that is going to be true or not. But it's not going to be that suddenly we woke up one day and like half of the economy does not have a job. It's not going to be like that. Like it's again, we are living through this. There are changes happening. We'll see some evidence of massive changes happening in the labor market, but they are accompanied by other changes that kind of balance it or make it complex to make clear one-sided argument, things like that. So it's going to be this sort of gradual change because of this human organizational institutional change bottlenecks that exist in our society. And so when you look at like performance in terms of benchmarks, they are capability in a test environment. So GPT-4 passing the bar exam is only possible because you gave it to it in like this sort of very specific environment where it works. But labor markets measure deployed usefulness inside of institutions where the situation in which it is deployed is very different. Like there's already existing workflows, existing knowledge, and so on, like where the AI may or may not function that well, at least in complementing user experience. Okay, so that's the second one. The first one we said was to look at this difference between methods, adoption, and impact. Second one is availability is not adoption. The third one we want to see is that this democratization of AI is not automatic. This is from this Madeline Depp and so on. They have a perspective in Nature Computational Science very recently. So here, like we want to see this sort of conditional democratization frame, like which is that AI might expand access to knowledge work skills, but only if the adoption gaps, task fit, and institutions line up. So again, we look at three aspects here. One is who has access, guidance, permission, and confidence to use AI in real work. Which tasks produce equalizing gains rather than bigger gains for already skilled workers. And then the third is who receives the surplus, workers, firms, platforms, customers, or capital. Like again, this is something that we need to be very carefully thinking about when thinking of the effects of AI, because we will see some evidence that this is already happening. And unless we constantly think about this sort of democratization as a clear objective for us when deploying AI, there's going to be winners and losers. And usually in our current world, in our system, like the losers are always going to be the people who are underprivileged, right? Like so, either in terms of skills or resources or money or power in some sense. Like so, we really have to be very careful. Thinking about like AI and its impact in the future because of these, right? Like so, who has the access, who benefits from it, and who gets the rewards from it. So separate access to knowledge work tools from actual participation in and reward from knowledge work. So you need to really think of these as two different things. That's the main argument that's made here. And the final point that I want to make about this discussion of AI and jobs is this idea again from Narayan Kapoor that a job is not a task. Not one task. A job is a bundle of tasks, right? Tasks are things like writing, coding, summarizing, persuading, scheduling, diagnosing, supervising, repairing, so on, right? Like these are individual tasks. So if you take an AI currently, you can do very well in writing, coding, in summarizing, in scheduling, persuading, probably, right? Like things like that. Each of these individual tasks, an AI can do very well, but when you put them together, it may not work very well together. But as a job of a human, like in my current job, for instance, there is writing, there is summarizing, there is scheduling, but my job is not like just a sequence of these. Like it's not like I write and then I summarize and that's not my job. Like so I can do this and that and this and that and this. Like so it's current AI is not is thought of in terms of perfection, in terms of tasks, not a job. There are things like tacit knowledge, local norms, client history, databases, liability, privacy, trust, law, legal, and so on, right? But this can this varies across different jobs, and so each of these tasks, like summarizing, for instance, might mean one thing in a legal job versus an academic job versus a freelance job, right? Like so, they are different things. And then there's also the power aspect here, like who decides how the tool is used, who captures the gain, and who absorbs the mistakes. So this is also something similar to that democratization argument that we made. So AI often automates tasks, but not jobs necessarily, because whether that task becomes a job and um, job leads to job redesign and higher output is a separate question. So these are two different things. So these are some things that we need to remember. So the four things that to keep in mind is this methods distinction between methods and adoption, applications, and impact. Availability is not adoption. Democratization is not automatic, so that's something we need to keep in mind. And then a job is not a task. So now let's look at the anti-panic case before we look at the evidence that we currently have in the market. So the anti-panic case is like, this is a case being made by David Oakes, and also who is like a popular Substack writer. He has this very popular piece about this worrying about jobs, AI job loss, very recent piece. So I just included that. I read this recently. David Otter, like another MIT economist, also has a similar take. So it's also a similar argument. I mean, this is a Steelman. Like, it's not a empirical proof, but we can try to think of this and then look at evidence whether this argument is supported or not. So the first one is the piece of like comparative advantage. It is that even if AI has an absolute advantage at many tasks, human labor persists when human plus AI is better than AI alone, right? So that's, I think, very important to think about. Like when thinking about jobs is wherever, like if human plus AI is better than AI, I think we will still have a comparative advantage as humans. So unless AI is better than human plus AI, where human is actually leading to degrading performance, and like there are many jobs like that where having a human will actually degrade the performance. So those jobs will probably go away. So there's this comparative advantage of having human in the loop. And when you're thinking about your own job, think about how do you place yourself in the AI loop. Again, this is bound to happen in the next X years. X can be whatever, 2, 3, 5, 10 years. But all our jobs will become like this, where it will be AI, especially knowledge work. Uh, so we need to be thinking about how do we complement the AI. How do we include AI? For sure, like if you're not including it, someone else will force it down your throat and include AI in your work. And how do we complement what the AI can do for us? The second is the Narayan Kapoor argument, which is about bottlenecks. The institutional move is in response to this is bottlenecks, like things like law, the legal policy, other things like trust. Like, do we trust the outcomes, preferences, norms? Do you whatever, like, yeah, how do you measure the productivity of humans plus AI? Legacy systems, obviously, AI is good at doing something, but we've had things from 20 years. Like, how do you make sure that AI helps in that? Maybe AI cannot do anything in there. There are also things like institutional, organizational politics. These mean that the capability does not become a substitution immediately. And then there is demand. If the output gets cheaper and the demand expands, the productivity gains can be more production rather than fewer workers, right? Like, so this is a really, again, like a Steelman case, but is important to make is, and a lot of the AI folks make this kind of case, which is that everyone becomes more productive. So because of this human AI interaction, and that means that we will have many more things to do. And examples given are the sort of radiologists. Okay, radiology, in 2016, maybe, or maybe in 2020, like someone predicted, like a Nobel Prize winning scientist like Jeffrey Hinton predicted that radiologists are not needed, are not going to be needed in 2025, something like that. But now we need radiologists a lot, because the AI can do radiologist jobs very well right now, but radiologists are now doing this sort of complementing the AI a lot. So they are able to solve more cases, take more patients, a bunch of things like that. So this kind of argument is again like very interesting, very important. Again, it doesn't mean that this is going to happen. It doesn't mean that this is not going to happen. But I think this is a good anti-panic case that if this happens, that's the best world, like where we're all more productive, we all have our own have our jobs, and things like that. So the limit is that the mass unemployment rhetoric, while preserving this like employment, right? It does not provide protection for every worker, right? Even this case of demand improving productivity and then everyone having more work is not really going to be the case. So I think David makes that case that there are different people in this ladder of an organization who might be safe or not safe depending on what kind of work they do. And the ladder looks like this. So one is there's a model that can do a task, and there's a product that exists, and the firm adopts that product. The workflow changes. Based on that workflow, the output changes. The output that the product can produce changes, and then that leads to this change of jobs or wages. So the again, like this is one of these versions of the Narayan Kapoor framework, these method, application, adoption, impact kind of framework, but by David Oakes. Here is this sort of like there are different cases in which, like for instance, a benchmark or a survey or a randomized control trial or job posting study, and they're not interchangeable because they're measuring different things here in this sort of rung, right? So we are mostly thinking of this rung 6, which is at the far most right, with all the political anxiety of people losing their jobs. A lot of the hype is that on these rungs 1 and 2 is that okay, these models can do a task, and then there's a product that does this kind of task. But we really have to be looking forward to how this happens. The middle 3 ranks, which is the adoption, and then changes in workflow, and then changes in output. We don't have really good clarity on that. Okay, before we go to the evidence, we want to look at like what we should measure based on what we talked about until now. So we will look at like productivity. So can the same worker produce more faster with higher quality? Task redesign, like which part of the jobs will become automated, easier, harder, or more supervised? Do firms hire fewer juniors, fewer contractors, fewer support staff, or the other way, right? Like fewer, advanced whatever senior people, because the junior people can just are cheaper to hire, can supervise many more AI agents that replace the senior people, whatever, things like that. And then power. This is also in terms of the sort of democratization frame. Does AI increase worker autonomy, or does it lead to more control and things like that? So here, like I think we'll get back to this. So usually when you're talking about jobs, we look at unemployment numbers, but as you see, when we're looking at thinking of like properly measuring this, we don't think of unemployment as a measure at all, as a metric, unemployment rate, because we'll see that it has a lot of problems. We should really be thinking about this in terms of productivity, in terms of how the tasks should be redesigned, in terms of who's going to be impacted by the hiring or like reshuffling of the kind of jobs, and then what is the power, who's going to have the power in making these decisions. Okay, so in terms of actual evidence, this is evidence from Anthropic, which looked at Claude conversations. Like they have all the conversations that we make with Claude, and they mapped each conversation to this ONET categorization, which is just like a BLS, like Bureau of Labor Statistics, has this categorization of jobs. So So they map that task list to that job, the prompts, whatever people are submitting to that job categories. And you see that currently, again, this is from 2025, so a year and a half ago. So which is like eternity in AI timelines, but still, like, okay, early adoption was mostly in software, like computer and math, software and writing. They dominate the most of the stuff. Like most of the jobs are not necessarily in there. I think maybe 5% of the economy is software jobs or something like that, like a smaller portion. So yeah, we still have very significant concentration in where these models are having impact. But usually things like office and admin, business and financial, this is where a lot of people are working in. Like, but that has AI has it not yet come to that, at least for now. Uh, and then you also see, so also something that we talked about here in this thing is task redesign and all that stuff. So is AI used for automation or augmentation, right? Like is so that Oak's paper makes this argument of comparative advantage, right? Like where if it's human plus AI is better, then that's the good case. So that's the augmentation part. So here the same model looks different in different product contexts. So in terms of chat, like it's mostly automation, yeah, around whatever. Mostly augmentation, like around 43% is automation, and it's increasing over time. But in terms of the API, which is the automated versions of this, and Cloud Code, which we have tried to use, like with the agents, it's mostly automation. Like so, people are just giving it the task. So. Uh, uh, okay, so that's the first one. The second one is in terms of second evidence is in terms of broader adoption in the market. So here there is this these big Blandin and Deming. They have a ongoing tracker. It's at this GenAI adoption tracker.com. If you go here, you'll see some sort of tracking. Like the last I saw is in I think February 2026, so 6 months ago maybe. I think they update every quarter maybe. But what they found is, okay, these numbers are very old now, like, but it's roughly similar. Like, I mean, a slightly bigger now. It's maybe 50-60%, but the trend overall here makes is similar, like which is that any generative AI use is around 40%. Maybe now it's around 60%. Any use at work is 23%. Now it's maybe 40%. Used every day at work is like 10%. This is in 2024 December, but now it might be a bit higher. But the most important thing is time savings. So how much time is being saved because of the use of generative AI? So that's reportedly around 1.4% of their work hours are being saved by generative AI. This I just saw was up to 2% now. So 2% is not a lot, right? So this actually supports, with evidence. This is self-reported evidence. So it might be a bit biased, but roughly directionally, this is correct that the normal technology frame, which is the availability is fast, like a lot of people are using it, but diffusion is slower. Explains why we're not seeing any massive labor impacts yet, even though the capabilities exist. Okay, there's very clear evidence in certain areas, like for instance, customer support there's very clear evidence. This Brynjolfsson, Lee, Raymond, they studied 5,000 customer support agents, and the generative AI assistant increased issues resolved per hour by 15%. So this is a very significant increase. And what they show here is that the gains were largest for newer and low skilled workers, and the tool helped them use patterns that higher performance had already learned in the job. So the AI tool could help the new users level up. The paper also reports improved customer interactions and worker learning channels through interaction with AI. So here, what did AI do? It helped compress the learning curve. Like, so it really helped the novices benefit because more the AI surfaces patterns that they have not learned through experience. The experts benefit less because much of the tools advised resembles what they already know. Like, it seems to state the obvious. And managers may redesign staffing if fewer juniors are needed to handle the same volume, right? Like, our uh, this is clear first evidence of this sort of disproportionate impact. AI can democratize skill, right? Like, that's what we saw here. Like, the junior people are able to learn and democratize, but also AI can reduce the demand for entry level learning by doing, right? Like, so most of our jobs, if you have been on the job market, is learning by doing. Like, we learn on the job. But if your AI is flattening that curve, right? Like, it can also reduce the demand for these sorts of entry level jobs, which where you learn on the job and become better. Okay, so the paper also shows this sort of equalizing of some tasks and amplifying the others, and there's a lot of other evidence in this space, like you see here, which shows the opposite. Like, so it equalizes some tasks, it amplifies others. So equalizing is that there's clear, like in jobs where there is a clear success criteria in distribution examples, meaning these are examples which the AI has already seen in its training, like quality control. So in customer support, maybe the the outcome is not of that high importance, so I might be fine. Uh, Exam, like, things like support or standard coding or exam like legal writing. Like, so if it's an exam like legal writing, there's a clear rubric for evaluation, but in a real use court case, it might be different. Uh, then there is also this sort of skill biased outcomes, which is that the creative open-ended tasks, where the hard part is choosing which AI suggestion is actually good. So there it might have disparate impacts, like, meaning in some cases it might be good, in some cases it might be bad based on what we choose. Then there's also the mechanism in which models are stronger at brainstorming than discrimination, and here, like, the human taste and domain judgments still select the most useful outcome. And finally, the policy that helps in like equalizing cases which call for gain sharing, and skill-based cases call for training, judgment building, and redistribution. Um, so let's I mean, I think this is something that we've looked at in the past, looking at evidence for like cases where there is a clear feedback loop, like where there is a correct answer or not. Like, in our agents lecture in week 4, we looked at why coding agents work relatively well, because the verification is often available, the code runs or not, the output is correct or not, things like that. So coding is the bull case where there is evidence is cheap, and so there's a lot of evidence that shows that, GitHub Copilot, for instance, people ran a study on that, and they found that developers completed standard tasks much more faster, 56% faster. But there's also this other study where there's an open source project and Copilot adoption associated with higher project productivity and participation, but also longer integration times. So took a lot more human effort. Uh, and yeah, coding is special because it has this sort of feedback mechanism. But coding evidence is now mixed. So there are, again, like we saw, this has some heterogeneity here. So there are certain tasks where the productivity boosts are much higher, and in this sort of open source RCT, like what they show is that it actually leads to these other bottlenecks, which leads to degrading the performance. So the patterns are mixed. So there's some of the strengths are in bounded digital tasks with cheap verification, things like coding exercises, draft summaries, data cleaning with checks. It's useful with the human in the loop knowledge work, where the worker can verify and steer things like support, writing analysis, and so on. It's risky in high context decisions with weak feedback. So in hiring, legal strategy, medical advice, open-ended agents, and it's really a bad fit in cases where there is some sort of human judgment absolutely needed and taste. So this is tacit, embodied, relational, institutionally constrained work where context cannot be pasted into a prompt. So legal work, right? Like for legal work, a legal case depends on a lot of what the arguments that you would anticipate the other side to make, and like that is not something that you can clearly articulate unless you know what the other side is thinking. And so it's a lot of context that is in the lawyer's brain or whatever the team's brain, but not cannot be captured. Okay, so yeah, we talked a bit about this. So when we're thinking of jobs, we should not look at unemployment rate. Unemployment is a really wrong signal because firstly, it's noisy and lagging. Noisy because it really tracks various other things. So if there's bad interest rates or business cycles or sectoral shocks or immigration effects or demographics or things like that, like there'll be unemployment will be impacted. So unemployment cannot be trusted like as a metric that measures the AI impact. And AI effects can show up also without layoffs, so without unemployment, meaning the firms can hire slower, not replace attrition, outsource less, uh, or ask the same team to do more. Uh, Productivity can become output, not job cuts, right? If demand expands, so AI might increase production and employment in some firms. So this can compensate for people being laid off in other firms. We also need some more granular evidence. So things at occupation, task firm, and wage data will help. And so here already have some data like this, and what we see is compression at the edges. So we have two studies already that shows that certain types of people are being impacted much more. So uh, there are fewer postings or change requirements before the layoffs appear in payroll data. And tasks that are used for training the juniors can be automated or absorbed by seniors using AI. This is happening in academia as well. Like for instance, tasks that I used to require a student to work with or things like that. Now I'm just outsourcing it to AI. Uh, Freelance, we've seen a bunch of effects: writing, translation, design, routine coding. These kinds of markets can adjust faster than traditional firms, and we're seeing a lot of impact there. And So even if there is this headline of massive no mass unemployment because of AI, there might be things that might be changing. So one of the strongest signals is from this sort of payroll data. ADP runs payroll for a large ADP is this company, large sector of Fortune 500, so large fraction. So you can clearly, if you use ADP payroll data, then you aggregates, then you will see some aggregate trends. And what this Chandar, Brynjolfsson, and Chen, what they find is that early career workers. So this is very clear right here. This is software developers. The rate of change of jobs pre and post ChatGPT. So post ChatGPT, the blue and orange line, which is early career 1 and early career 2, 22 to 25 and 26 to 30 years old. How are they changing? Like you can see the orange and blue lines are the only ones going down, meaning relative to previous hiring, this hiring is going down. Obviously, this is one study, but you cannot measure causation. So tech hiring was already stressed by COVID and other layoffs and things like that. But yeah, the paper is well done. Like so, it does a lot of robustness checks that this finding of the impact on younger people, younger cohorts, and we also see this yourself, right? Like, so if you're on the job market now, things are a bit different. Like, I don't know if they're good or bad, like, but they're definitely different than what it was a few years ago. Uh, And so the right takeaway from this is that any evidence consistent with AI-driven junior compression is not, settle of labor economics. Okay, so this is an important conceptual point that we should be thinking a lot about in the economy when we think about jobs and so on, is the role of this sort of junior jobs. It is not just that the young people are losing jobs, it's also about the reproduction of expertise. So this like is a very important question. So entry work is not just cheap labor; it's also a training pathway to other jobs. You know, every senior person comes from learning on the job. Like I mean, we've been making this point again and again. So the ladder is you do routine tasks, learn the domain, build judgment, earn trust, and move up the ladder. But now with AI, the routine tasks disappear and become AI mediated. So juniors are expected to supervise before they have experience, supervise either others, humans, or other AI. And so they're not having the chance to learn on the job. Sometimes, some of the jobs like customer service we saw might be okay because they're the learning on the job. The AI can help with that, but a lot of the jobs AI may not be able to help. And so here it's something that's very important is that the institutional knowledge, I mean, there should be some institutional ways of fixing this, especially if you're running a company, you should be thinking about training, apprenticeship, evaluation, mentorship, very intentionally think a lot about these. So there is a lot of evidence on this that this PricewaterhouseCoopers report, jobs barometers reading has shown is that the jobs are being seniorized, meaning even the junior roles are which are AI exposed, are much more likely to demand skills that are historically associated with senior work. So they are I mean, jobs where the employers are demanding more judgment, leadership, stakeholder skills, because routine junior work is now, AI can do that routine junior work. And I think you will face that also in your job prospects. And I think wherever you can, like if you can think of using AI to upscale yourself, I think that's something that it needs to be kept in mind. So AI also creates a lot of hidden work for the good and bad. Like for instance, we saw some of these few weeks ago, which is the training and evaluation requires people. So these are new jobs requiring data annotation, reinforcement learning, human feedback, red teaming, benchmark construction, benchmark evaluation, content moderation, prompt testing, a bunch of things like that which come and go. And this labor is often low paid, outsourced, and invisible. So, again, like without ChatGPT, when it came out, like people were amazed by how well it works. But then it came out that a lot of this was because OpenAI outsourced a lot of this RLHF to companies in Kenya, which were doing this cheap labor and so on. Uh, so, I mean, AI replacing labor is not complete, like not correct, like it creates these new jobs, but maybe we don't want these. I mean, it's not a desirable job to do a $2 an hour like data annotation or checking AI's outputs or things like that. Um, okay, then there's also the issue of like democratization and distribution of power. So one is we know that a lot of this generative AI revolution is built on top of copyright theft, a lot of stock images, illustration, all of these music, all of these were existing artists' work has been used. So the question is like whose work is the model trained on, who gets consent, who gets compensation, who controls the reuse of this, and like there are evidence of like cases where this worked, like for instance the recent Hollywood strike maybe 2 years ago already now, is workers negotiated how AI could be used, could use their likenesses, scripts, and performances. So this is a good example of positive outcome where workers had protections already like negotiated for the future that was coming up. But this is something that is very important. Is you trained a lot of these on top of creative outcomes, but will lead to the loss of creative jobs in the future. Okay, the final point I want to make is in terms of this distribution is the productivity gains do not decide who benefits. So one is the workers could gain time, skill, wages, autonomy, and access to higher value tasks. So that's the best case scenario. The firms could capture the gains as lower headcount, faster output, tighter monitoring, and market share. And then the capital could capture gains if AI raises returns to compute, data, platforms, and proprietary models. And here's where Darren Acemoglu, a Nobel Prize winning economist from MIT again, he warns that even real world productivity uh, um, gains can widen this capital labor gap. Like so, if your existing whatever laws and regulation does not take this into account, of this gap between who benefits and where the productivity gains go. Like if, for instance, yeah, AI helps in improving productivity, and if it all goes to the capital bucket, like where AI is your investments are paying up and it goes back to Wall Street instead of the workers' pockets, that's not a great thing. Uh, so, so this is the slide that talks about AI is not just a tool access; it's also about who uses it, right? Like so, the adoption will skew by education, income, age, gender, training, and so on. So where it spreads, like things like language, does it spread beyond just your Silicon Valley and in the global north and so on? How the rules work, like things like blanket bans, can make hidden use worse. This is very important because if early adopters capture compounding returns, then AI can democratize knowledge work for some of them while widening the distance for others. And this is my argument as well in making this sort of AI should be widely used because if everyone uses it and knows the power and knows how to use it, then we can make the case that this sort of difference of haves and have-nots will not be that bad. Uh, Okay, so just the final optimistic and pessimistic case based on all the stuff that we've talked about. So the optimistic case is this is again a Steelman, assuming like this thing will happen. AI could extend expertise. So this is also the argument that David Otter, the MIT economist, makes, is AI can help rebuild middle skill work by letting more workers use expert judgment with support. So it requires a lot of training, certification, liability structures, and tools designed to augment workers rather than bypass them. So this is very important that this happens. If this happens, this is a good benefit, right? Like so here, you can think of things like nurses with clinical decision support, teachers with individualized feedback systems. So you don't think of replacing teachers or nurses, but think of making them more productive, like we saw with making the radiologists more productive. I think that's a best case scenario where all these people are upskilled. Now, your nurse can do a much, much better job because they have access to all these clinical decision support systems and so on. The pessimistic case is that AI could also de-skill and discipline labor. So this we already saw this case of AI like not helping the junior workers because they're left with monitoring what the AI does, exception handling, or accountability for machine output, or AI can help in like surveillance and things like that. So more measurement does not automatically mean better work. There's also this sort of distribution of power. So workers cannot negotiate deployment. The gains become layoffs and the lower autonomy and more precarious work. Again, this is more likely the future, at least in some fields. Okay, just to quickly summarize the arguments, right? Like is AI going to impact the jobs or not? So AI can make some workers faster, more valuable. AI can also commodify the tasks of some workers. In terms of outputs for firms, AI can expand the output of one firm and hire more people, but for other firms, it can freeze hiring and reallocate work to seniors. In terms of sectors, AI can augment expertise in one sector, it can de-skill laborers in another sector. Based on this evidence we've seen, here's my summary. So the strong points are bounded task level productivity gains we've seen in many fields like customer support, writing, coding context. Uh, Actual use data also shows that AI is concentrated in knowledge work currently, like in software, education, analysis, office tasks. So this is where we have strong evidence for. In terms of emerging evidence, we also see this sort of early career compression to AI exposed jobs and seniorization of junior postings. What is unsettled is wage effects, like will AI increase wages, decrease wages, uh, economy-wide and employment effects, adoption divides, long-run expertise formation, who captures these gains. Like these are not very clear, it's not settled. We don't have any claims based on the data that we currently have in June 2026 for imminent mass unemployment from just the performance metrics alone. So, I mean, I hope you've all worked on the agent assignment, but that's again, like as I use these agents a lot myself, like I really get a sense of like what the effectiveness of some of these, at least in my kind of jobs, will be. It really automates a lot of my job. Hopefully it would have given you some sort of labor market evidence at a small scale. And so, you can ask yourself, like, at least in your field, in the area of work that you are doing, like, how does it, like, what does this look like? What is the impact of an AI agent? Look for new human tasks, like, specifying, prompting, verifying, debugging, managing context, deciding when to stop, things like that. This is my take on it. Like, these are what I think of and what I've been doing with AI agents. Uh, in terms of connection to today, like if this becomes your workplace standard, right now nobody, at my university is forcing me to use an AI agent. But if I mean, already in some of these software companies, AI companies particularly, there's this thing called token maxing, where people are evaluated based on how many tokens they use. If it becomes a standard workplace process, who would gain the skill, who would lose practice, who would be accountable, and so on. And final slide is about reading AI and jobs claims. We already talked about this, but just to recap, before agreeing or pushback, think of it like where does it fall on the evidence ladder? What is the unit, like task, job, occupation, firm, sector, or economy? What kind of evidence? Is it a benchmark, a survey, RCT, job posting, payroll, case study, forecast? What is the counterfactual? What would have happened without AI? uh, who captures the gains, and what would change your mind, right? Like, and this is something that we talked about last week. Is some of these are really important to have an open mind on, because these are things that are changing rapidly, and might be different from what you had anticipated, and so it's important to keep an open mind on this. Yeah, so think about this, and let me know if I missed something. And yeah, looking forward to your discussions. Thanks.